Welcome to Precalculus Concept 12C, quadratic functions. We're going to determine the quadratic's minimum or maximum, and there's only two boxes. So here's box one. The whole idea underneath box one is understanding this notation of negative b over 2a comma f of negative b over 2a. So this is my whole point of this box is to make you realize that this right here is nothing more than a location, an XY location. That's all it really is. But more importantly, it's a very specific XY location that I want you to get. So take a look at this quadratic. For example, I have negative x squared plus 4x plus 1. And what I've done is I've graphed it for you over here in fluid math. And here's the picture of the parabola, and of course it opens down. We're going to learn that because the a value is negative. But what I want you to do is I just want you to consider where the vertex is in this particular picture. Okay, so right now I want you to figure out where the vertex is in this picture and write it down real quick. Okay, now that you've got where the vertex is, let's do a couple of things here. So the first thing I want to do is we're going to understand what this means, okay? This and this notation. So in this quadratic, I'm going to write down the values of a, b, and c, okay? This should look familiar to you. The value of a is negative 1, the value of b is 4, and the value of c is 1. So far, so good, okay? Now, I'm going to evaluate negative b over 2a. Okay, that's going to give me negative 4 over 2 times negative 1, which gives me negative 4 over negative 2, which is equal to 4 over 2, which is the number 2. Okay, awesome, the number 2. Hopefully this is starting to look familiar to you, or you should notice something. Now, if I take that 2 and I drop it right back down into the function itself, I would have this, negative 2 squared plus 4 times 2, and then plus 1. So all I did was I took the 2 and I substituted right back into this x and that x. So look what I get. I get negative 4, and then I get plus 8, and then I get plus 1. Negative 4 plus 8 is 4, and 4 plus 1 is, oh my gosh, 5. So you should be like jumping up and down right now and realizing that the point 2 comma 5 is exactly the same as the vertex over here. This is what it was. It was 2 comma 5. So hopefully you realize this. You're putting this together, right? There's the vertex. Well, if I can actually put this on the graph, but it's really mad at me right now. Let's just pretend that it's there. Okay? So what this means is, the whole point of this is that this part right here, this negative b over 2a, it gives you the x-coordinate of the vertex. It gives you the x-coordinate of the vertex. Then, once you get that value and you substitute it back in, that's what this part means. That means this f of negative b over 2a. You just take that value and you substitute it back in, and out pops the other value, the y value. So we have 2 comma 5. So this right here tells us the quick and easy way to find the location of the vertex. Okay, here's box number 2. It's an example, and we're going to consider the quadratic function f of x equals negative 3x squared plus 6x minus 13. So we want to determine whether or not it has a min or a max and where it occurs. And then we want to identify the domain and the range of this thing. Okay, so to determine whether or not it's a min or a max, we take a look at the a value. So let's write down what we know. We know that a is a value of negative 3. We know that b is a value of 6. And we know that c is a value of negative 13. So far, that should not be a big deal. This thing is going to have a maximum. The reason it's going to have a maximum is because the a value is negative. So that means that this parabola is opening downward. That means that it has a high point, so that means that it must have a maximum. Okay, let's figure out where it occurs. So let's find the vertex of this thing. Okay, so I want negative b over 2a and then comma f of negative b over 2a. So negative b over 2a gives me the following. It's going to give me negative 6 divided by 2 times negative 3. That is worth negative 6 over negative 6, so that means I have a value of 1. Then I take 1, I drop it right back into the function itself. So that was going to give me negative 3 times 1 squared plus 6 times 1 minus 13. This is going to give me 1 squared is 1, so that's just negative 3 plus 6 minus 13. negative 3 plus 6 is a positive 3 minus 13. That gives me a value of negative 10. So I have found the location of the vertex. It is located at the value 1, or at the point 1 comma negative 10. Okay, so the vertex has a maximum and it's located at the point 1 comma negative 10. And then the second part of this question wants us to identify the domain and the range. So for this, I'm going to take a look at the picture. So here is negative 3x squared plus 6x minus 13. And I'm going to draw the picture up on the graph here. Now notice we said that the vertex was at 1 comma negative 10. So let me adjust the scale a little bit. And yep, there it is right down there. It's at 1 comma negative 10. So for the domain, okay, the domain of any quadratic function is going to be all real numbers. Anytime you have a quadratic function, it's going to be all real numbers guaranteed. The range is going to be all the proper values of the y variable. So in this case, you can see that the y values begin at negative 10 and go all the way down to infinity. There is no y value for 6 or for negative 7 or negative 8 or negative 9 or anything above that for that matter. So therefore, one way we could represent the domain is we could say it is the set of all real numbers y such that y is less than or equal to negative 10. That's one way that we could do that. So all real numbers, sorry, this thing's messing up here. All real numbers y such that y is less than or equal to negative 10. So basically anything that is smaller than negative 10 is going to work for us. So that's one way that we could represent the domain and the range for this function right here.